The purpose of this video is to illustrate the pumping capabilities of positive displacement sliding vane pumps in moving high viscosity liquids. Positive displacement sliding vane pumps provide superior performance over all other positive displacement pump technologies in moving low viscosity, thin liquids such as refined fuels, LPG, refrigerants, liquid carbon dioxide, and ammonia, to name a few. Vane pumps are clearly the pump of choice in thin liquid applications. But it should also be known that vane pumps are very effective at moving high viscosity liquids in the range of 50,000 SSU and higher. In this video, we will review basic vane technology principles, compare this to the principles of an internal gear pump, provide an overview of various viscosity ranges, and demonstrate vane technology effectiveness in pumping high viscosity liquids. Sliding vane pumps provide superior mechanical performance and up to 24% greater energy efficiency than gear pumps. Vane pumps have a number of non-metallic vanes that slide into and out of slots in the pump rotor. When the pump shaft turns the rotor in the pump casing, centrifugal force, rods, and/or pressurized fluid cause the vanes to move outward in their slots and bear against the inner bore of the pump casing to form pump chambers. The fluid is passed around the pump casing to the discharge port. Each revolution displaces a constant volume of fluid. Variances in pressure have minimal effect. The sliding vanes self-adjust to maintain internal clearances throughout the operating life of the vanes. Energy-wasting cavitation is controlled, and low energy consumption is maintained. External gear pumps are less mechanically efficient than vane pumps and consume more energy. Liquid enters the pump chamber through the inlet port. The pump chamber consists of two rotating metallic gears. As the gears rotate and come out of mesh, they create a void. The volumes are reduced, and liquid is forced out the discharge port. Each revolution displaces a constant volume of liquid. Variances in pressure have minimal effect on pumping performance. However, because the gears actually cut the liquid as it enters the pump chamber, gear pumps should not be considered for moving shear-sensitive liquids. The metallic gears wear over time, resulting in wider clearances. This increases energy-robbing slippage and significantly decreases volumetric efficiency. In order to compensate for the performance degradation, pump speed is increased, which requires greater energy consumption. Now let's take a look at some of the various liquid viscosities Blackmer vane pumps are effective at handling. This sample is 30 SSU. It is the viscosity of water. As you can see, it flows very easily. It is considered light viscosity. Next we have 320 SSU. This is the viscosity of light oil. It too flows quickly and easily. The next sample is 4,000 SSU, the equivalent of honey. Being a little thicker, it does not flow as quickly or as easily as the previous examples. The next sample is that of heavy motor oil, 45,000 SSU. It flows much slower than the previous examples. The final sample is 4.5 million SSU. It will flow, but very, very slowly. In any case, Blackmer pumps, properly sized for the application, can pump these liquids. In this sequence, we will demonstrate a Blackmer TX V3B pump, pumping a high viscosity liquid. This particular liquid is 50,000 SSU. This is the equivalent of 50-weight motor oil at 20 degrees Fahrenheit. We are looking at the inlet pressure, discharge pressure, and differential pressure. We are operating at 35 to 37 psi. This is the GPM, the horsepower, and the RPM. At this point, we're pumping 50,000 SSU at 115 gallons per minute at 275 RPM using about 6 horsepower. Using a TCS brand flow meter at 275 RPM, we can see that the pump performs precisely to the recommended performance curves for this particular pump and application. As we increase the speed to 400 RPM, the pump delivers 150, 160, almost 170 gallons per minute at 55 psi. This demonstration illustrates that vane technology performs very effectively in moving high-viscosity liquids, in this case, 50,000 SSU, at both high and low speeds. Sliding vane pumps are exceptional for thin liquids, but as this brief demonstration illustrates, they are also excellent for moving thick liquids, particularly when operating at slow speeds. Standard vane pumps are available in speeds of 100 to 1200 RPM. Motor speed models run at various speeds, 950, 1150, 1750, and 3600 RPM, and pressure ranges from 125 to 200 psi. Sliding vane pumps offer superior suction lift and line stripping capabilities, and their self-adjusting vanes eliminate energy-robbing slip and capacity loss associated with gear and lobe pumps. As a result, vane technology provides superior high mechanical efficiency and energy savings over other positive displacement technologies. So, when your application calls for moving thin or thick liquids, consider the high-performance energy-saving advantages of sliding vane pumps. Then, join the ranks of the most loyal and satisfied pump users from around the world and share in their common demand. Better get Blackmer.